Hello guys, we're talking about ionic radius today, and you can be excited because this is the last of our trends. Also, make sure that you go into the document, you find the document on notes, and that you make sure that you're putting in all the stuff that you need. More information can be found right here. Okay, so what do you need to know and do by the end of this? Well, you probably should know what ionic radius means. You'll also need to know the trends that we see. So what happens to the atomic radius as we move from left to right and from top to bottom? Does it increase, decrease, stay the same, a little bit of both? Well, you'll have to know that. You'll have to explain why. Why does the trend occur? So if it increases as we move from left to right, you need to tell me why. Why does it increase? Then you'll also need to know the difference between atomic radius and ionic radius. So remember, we've talked about atomic radius in the past, and today we're going to talk about ionic radius. You'll need to know the difference and be able to kind of compare and contrast them. You'll also need to order the elements from least to greatest ionic radius. Okay, let's get going. So, we've talked about atomic radius before. It's the radius of an atom. Well, I'm going to add something in here. The radius of a neutral atom. Neutral atom. So, what is a neutral atom? Remember, neutral just means it has the same number of protons as it does electrons. But, are all atoms neutral? No, they are not all neutral. We can also have atoms that we call ions. And ions happen when an atom either gains or loses electrons. For example, I could have a neutral nitrogen atom, which would have 7 protons and 7 electrons, but I could also have an ion of nitrogen. Well, what would an ion of nitrogen look like? Well, nitrogen, 1, 2, 3, 4, has 5. Nitrogen has 5 valence electrons. So let's figure out how many electrons would nitrogen want to gain or lose? Well, it's going to want to gain 3 because that's the easiest way for it to get to 8. So I could have a neutral nitrogen atom, but it is also possible I could have an ion of nitrogen, which would have 7 protons and 10 electrons. And you may be saying, well, does the radius of this neutral atom, is it really going to be any different from an atom that's gained 3 electrons and is an ion? The answer is yes. Actually, there is a huge difference in the radius between neutral atoms and atoms that are ions. So that's why we actually need to talk about both. So the ionic radius is the radius of ions. The atomic radius is the radius of ions. And remember, you can always figure out what ion or like what charge an atom will have by thinking about how many electrons it either wants to gain or lose to get to 8. Okay, so now let's look at the trends that we see for ionic radius. So don't get overwhelmed by this kind of crazy chart because the purple is actually showing us what we already know. The purple is the atomic radius. Where down here, this is the ionic radius. So let's just see our first trend. Let's figure out what happens to our ionic radius, which remember is in red, as we move down our chart here. What do you notice about our ionic radius? Well, it's getting bigger, right? It's getting bigger as we move down. It increases. Why does it increase? Well, you guys are probably pretty smart. You probably can figure out why. As we move down, the radius or the size is going to get bigger. As we move down, what do we get more and more of? We get more and more energy levels. So why does our ionic radius increase as we move down? Because we get more energy levels, which makes our atom bigger and bigger. So, okay. So now let's look at one that's a little bit more complicated. Let's look at the trend in ionic radius as we move to the right. Well, let's look at our positive ions, or our guys who are going to want to be losing these electrons. So we move to the right, they get smaller and smaller. But then, as soon as we get to the negative ions, or the elements that want to lose they want to gain electrons, it gets huge. And then it gets smaller and smaller. So the trend is in our cations or our positive ions, it gets smaller as we go to the right. It gets huge. And then it gets smaller. Sorry about that, guys. Then it gets smaller as we go to the right again. So why is that the case? Why does it get smaller, then it gets big, and then it gets smaller again? Well, let's talk about it I'm going to use sodium. This is magnesium. No, it's not labeled very well. And phosphorus. Okay, so let's think about what happens when sodium forms an ion. Sodium has one valence electron. So the ion that it's going to form is it wants to lose that electron. Okay? So this is the most common ion for sodium. It having lost an electron. Now let's look at magnesium. Magnesium has two valence electrons. So when magnesium is going to gain or lose electrons, it's going to choose to lose 2 electrons. That means that magnesium is going to make ions that are 2+ and sodium that are 1+. Well, what's the difference between these two Bohr diagrams? You'll notice that between a 1+ sodium ion and a magnesium 2+ ion, there's actually no difference except for one. Magnesium has 1 more proton than sodium does. That's the only difference. And as we've learned from past videos, the more protons you have, the harder you can pull on these negative electrons, and the more you can pull them in, the smaller your atom's going to be. So that's why we see that magnesium right here is smaller than sodium. It's smaller because magnesium has more protons, which means it can pull those electrons into it closer. You might be saying, okay, Miss Thiemann, yeah, I got that from other videos. But what about phosphorus? Why does phosphorus get huge? Why does it get huge? Okay, well, think about it. Magnesium, right? We got rid of 2 electrons, which means we only have 1 energy level. We only have 2 energy levels left. Phosphorus let's think about the ion that it wants to make. It's not going to want to lose electrons. It has 5 valence electrons. It is easier for phosphorus to instead grab 3 more electrons. Remember, these are going to form, they're going to form the ions. Ions will form because elements want to be stable. So phosphorus is going to want to gain 3 electrons. So this is the ion that phosphorus will want to form. However, and this makes a nice little 3 negative ion. But how many energy levels does this phosphorus ion have? It has 1, 2, 3. How many does magnesium have? When magnesium became an ion, it lost an energy level, so it only has 2, where phosphorus has 3. That's why there's this huge difference in size. That's why sodium is the biggest, then it gets smaller and smaller, then we gain an entire energy level, and we get bigger again with phosphorus. And then our radius is going to get smaller and smaller again because we get more and more protons. Okay, there's one more thing that we need to talk about. So we've talked about how and why we see the trends that we do as we move from left to right and up to down. Now what I want to talk about is why we see this difference in size from the atomic radius to the ionic radius. Why is sodium, a neutral sodium atom, so much bigger than an ion of sodium? Remember, we said that if sodium's going to be gaining or losing electrons, it's gonna want to lose its electron. So this neutral atom of sodium, originally it had 3 energy levels, right? 3 energy levels. But when we make sodium into an ion, which just means that we're gaining or losing electrons, it's going to want to lose an electron. And when it loses an electron, guess what? It only has 2 energy levels. So the reason that sodium or positive cations will be smaller than neutral atoms is because they lose an energy level when they lose their electrons. Well, now let's look at our anions, or elements that are going to want to gain electrons. So this is phosphorus. I always forget to label him. So you'll notice that a neutral phosphorus atom is smaller than the phosphorus anion. So why is that? So this right here is, I've already drawn, well, the computer's drawn, is a neutral phosphorus atom. When phosphorus becomes an ion, remember we said they have 5 valence electrons, which means it is going to want to gain 3 electrons. So let's look, what is the difference between our neutral phosphorus and the phosphorus that we have here, which is our ion? The only difference is that this phosphorus has more electrons. And you might say, well, why does that make phosphorus bigger? Well, the idea is that hopefully you'll remember that negative electrons, they don't actually like to be near one another. All these negative electrons are actually going to repel one another, meaning they're going to push each other away. And when we add these extra electrons. Remember, we haven't added any protons. You cannot add protons. We have not added any extra positive charges. We've just added extra negatives. And when we add those extra negatives in, there's more kind of negative charges trying to push each other away, which means that the ion, phosphorus with 3 extra electrons, will be bigger than phosphorus without those 3 electrons. Because when you add extra electrons, there's a lot of extra pushing going on, which ends up actually making your atom bigger. And then finally, actually, nope, I forgot. We already talked about that. So no, that is actually, this is the end. So that's why cations get smaller, because they lose energy levels when they lose electrons. And why anions get bigger, because when we add electrons, the electrons are going to push each other away. And it'll actually make the atom bigger as they push each other further away from each other. I hope that you guys are having a great day, and remember, if you have any questions at all, please let me know. I would love to help. Talk to you guys later. Bye.